A very warm welcome to all of you guys. Welcome to another revision session of mathematics. My name is Sibusiso, and as always, I'm very excited to be with you on another very awesome program that promises to be an eye-opening one. Remember, guys, this show is proudly brought to you with lots of love by Liberty. A very special shout out goes out to Liberty for sponsoring this awesome show and helping us to be here with you and guide you through any of the challenging questions that you could encounter from wherever you are. If you haven't, like Mbali has already told you guys, make sure that you download our Tenfold education app, which can help you to be basically ahead of anybody who's trying to catch up with you, because you can then watch any of the videos that we have. They're awesome videos, guys, that will help you with the basics that you could be struggling with in order for you to benefit from the program, because you can also send questions to us using the app. And Mbali will tell you all about that. So keep watching. And like I always encourage you, if you know people who are not watching the program at the present moment, please hop onto your socials and let them know that they're missing on the opportunity to multiply the content coverage tenfold and beyond. Well, like I said, on today's program, we're going to be focusing on revision. So I'm actually very excited because I saw a whole lot of concepts from paper 1 and paper 2 questions. I'm very excited about that. And without any waste of time, let's jump right into our first question and see how do we actually work with that. Okay, so this one is a question that comes from Ikaning. Thank you very much, Ikaning, for sending us this awesome question. It looks like it's a question that is based on differential calculus, cubic functions, to be specific. So let's look at it and try to analyze it together and help you to understand how do you work with cubic functions, because we all know that in every paper 1 exam, you're always going to get questions that touch on cubic functions. So we are given that f of x is 2x cubed minus 23x squared plus 80x minus 84. All right. Now, the most important thing that you have to take from our shows is basically the approach to the questions. The concept is what we are behind, not necessarily the numbers, right? Because the numbers are definitely going to change. Questions are going to change, but the concepts are not going to change. So we are given a function of f of x, and this function of f of x is 2x cubed minus 23x squared plus 80x minus 84, right? Now the first question is asking us to prove that x minus 2 is a factor of f of x. So what are factors? Well, you guys should know that if you're looking at a cubic function, and when you factorize it, it's going to factor to 3 factors, right? It's going to produce 3 factors. It's going to be x minus the first factor, x minus the second factor, and x minus the third factor. Those signs could be minus or they could be plus, right? Now, the examiner is claiming that one of the factors there is going to be x minus 2. Now, we need to prove that. What you should know, using the factor remainder theorem, that if I substitute the root that comes from that factor, and my answer becomes a 0, then that is proof enough that you're looking at a factor. Remember, if x minus 2 is equated to 0, and then you add the 2 on both sides, and you just try to substitute your x as 2 in your function, and the answer comes out as 0, that is confirmation enough that that is actually a factor of your polynomial. So I'm going to try and sub 2 here. It will be 2 into 2 with the power of 3. You've got 23 into 2 squared plus 80 into 2 minus 84. Then you're obviously going to go and fetch your calculator and try to figure out if it does indeed agree that the solution to this is going to become a 0. If it becomes a 0, then that's proof enough that indeed that is going to be the first factor of your polynomial. So if you've got 2 into, it's not 2, but it's basically 23. Okay, 23 into 2 with a square, and then you've got 80 into 2, close bracket, and then you're subtracting 84, right? And the answer comes out as 0. If it doesn't come out as 0, then it would mean that it's leaving a remainder. If it leaves a remainder, then it's not a factor of your polynomial. For it to be a factor of a polynomial, it has to give you a remainder of 0, which is what we're getting now. So after we get this, we can then clearly say to the examiner, okay, the answer becomes 0, therefore, it means that x minus 2 is a factor. Not x plus 2, but x minus 2. And if you check on the far right of my screen, this is basically what happened. If your x was replaced with 2, when you're going back, by subtracting 2 on both sides, your x minus 2 will be a factor. 2 is a root, x minus 2 is a factor. The second question is asking us to factorize f of x fully. It says hence or otherwise, factorize f of x fully. Okay, cool. Now, when I go to the second question, there are many methods of factorizing a cubic. You can use long division, you can use synthetic method, or any other smart method that you probably have been introduced to. So the technique that I use all the time is what I call monkeys eat apples plus bananas. Very, very important technique. How does that even work? Well, check this out. I need to divide my polynomial with the first factor. So what I simply do in order to use monkeys eat apples plus bananas, that's the technique I use all the time, right? You can obviously use the one that works for you. Monkeys eat apples, all right, plus bananas. Okay, this is my technique. Now, how does this even work? Well, first of all, I need to tell you something very interesting about your cubic function. The cubic function that was given to us says f of x is 2x cubed minus 23x squared plus 80x minus 84. Now, you guys have to know by now that this is in a form ax cubed plus bx squared plus cx plus d. That's basically the form of this equation. In general format, we can put it in that form, all right? So now what I'm going to do is I'm going to divide it. I'm literally dividing my cubic. So I'm going to say, okay, let's take this 2x cubed minus 23x squared plus 80, okay, x minus 84, and we literally divide it by x minus 2, the first factor that we found. Right, and now how is this going to basically work? Well, you take the first, you divide it with the first one. So I'm going to take this guy, I'm dividing it with that guy there. So which means 2x cubed divided by x gives us exactly 2x squared. Now there's going to be a monkey hidden in the middle. So there's like an mx term. There's a monkey term that is going to be hidden there in the middle, right? And then the last term that you're going to have is you take the last one, you take this number, you divide with that number together with the sign. So negative 84 divided by negative 2, this is going to give you an answer that is basically positive, and then it's going to be 42. Okay, so this is what I'm ending up with. When I do 2x cubed divided by x, I get 2x squared. 84 divided by 2, 8 over 2 is 4, and then 4 over 2 is 2, so that's basically what you end up with. And then you have to bring back your x minus 2 in order to complete your function of f of x. I simply do that, then I'm done. First divided by the first, the last divided by the last, and then there's a monkey hidden in the middle. Somebody's wondering, what is this m that you just introduced? That's where the monkey concept comes in now. So if I want to figure out what m is, I'm going to say monkeys eat apples plus bananas. What is my a? My a and my b are going to come from the cubic. Like I said, if you check on the equation there, the 2 that comes from 2x cubed, that is basically my a. So I have a 2 here. What is p? P is the root that you were substituting the time you were trying to prove a factor. The number 2 that I was replacing there in my function, that is basically going to be the p value. So I'm going to put a 2 in there. And then the banana is negative 23 because it's the b from the cubic function. So I'm sitting with 2 times 2 minus 23, that's 4 minus 23, that gives us a monkey of negative 19, right? So I'm not going to come here and say, okay, my cubic is simply 2x squared minus 19x plus 42, and then this must be multiplied with x minus 2. And then from here, you've got a quadratic, which is going to definitely factorize to 2 factors. Your x minus 2 has always been ready. You're just going to put it right there at the end. Okay, 2x squared comes from the product of 2x and x, and then your 42 comes from a product of 2 very exciting numbers. If you think about it, when you divide 42 by 6, you're going to get something very exciting. So I'm going to have 6 here, and I'm going to get 7 here, because 7 times 2 will give me 42. If you can't factorize that, the quadratic formula can still help you to figure out the solutions. I know that this is correct. Why? Because the product of this is going to be negative 7x, and the product of this is going to be negative 12x. The sum of negative 7 and negative 12 will give you negative 19, which is the middle term that you are interested in. So that's basically how your trinomial will simply end up factorizing to. Absolutely awesome. No complications there. It's just basic factorization, which is absolutely awesome and very useful in this case. So then that actually gives me my f of x completely factorized. I'm happy with 2x minus 7, x minus 6, as well as x minus 2. All right, let's go back to the next question. They're saying to us in 8.3.3, determine the x-coordinates of the turning point of f. We're looking for the x-coordinates of the turning point of f. Keyword there is turning point. Turning points are stationary points in your graph, right? So you're looking for the turning point. Now, if you're looking for the turning point, you've got to keep something very important in mind. We're looking for the turning points. Turning points of a graph are stationary points, okay? Stationary points. Now, in the stationary points, in the concept of stationary points, it means your graph is not increasing nor decreasing. It means it has a gradient of 0, right? So that's very, very important. A graph is stationary if it's not increasing and it's not decreasing. If its gradient is equal to 0 at that point, then it means that your graph is stationary. Now, how do we work gradients out in mathematics? Well, you just have to figure out the derivative. So we know that f of x was whatever we were given originally. We just need to find the first derivative for turning points and equate it to 0. All right. Now, what's the first derivative of this function that we were given? The first derivative of this function is going to just simply be 6x squared minus 46x plus 80 is equal to 0. So this is the derivative. I'm equating the derivative to 0. I'm deriving what? I'm deriving my cubic function, the 2x squared. That's where the 6x squared minus 46x plus 80 comes from. All right? Now, after doing that, you equate this to 0. And then I think by just looking at it, it looks like 2 can go into all these numbers. So I'm going to divide all of them by 2. I end up with 3x squared. I'm going to end up with 23x. And I'm going to end up with an answer of 40 is equal to 0. So I'm not sure if this can be factorized. It looks like it can be if you put 20 and 3 somewhere else. If you put 20 times, what is the product of? Okay, fine. If you can't factorize it, of course, you can use the quadratic formula. All right, quadratic formula, for those who probably still want to remember how it works, it's negative b plus minus the square root of b squared minus 4ac all over 2a. It's just good for practice. So we show you that you can always find these answers by using different methods. You'll have negative 23 here. You've got this, which is negative 23 squared minus 4 times a 3, and then you've got a 40 here, all right? Everything needs to be divided by 2 times your a value, which is 3. If this thing is done very well, you should end up with an awesome answer that is going to give you these x values that you're looking for, because you're looking for the x values of the turning point of this particular cubic. So let's go and try and put these things in our calculator. All right, so you're going to have a fraction here. You've got a negative open bracket, negative 23. You close the bracket here. You put a plus with a square root. There will be values negative 23. So you've got negative 23. And then, of course, you've got to put it in brackets. If you don't put it in brackets, the calculator is going to do something else, all right, which is not what you want to do. Squared minus and then 4ac. So 4 is a number, okay. A is 3, okay, and then your c value is going to be 40. Everything divided by 2 times something. What is something? Well, something is 3. You put a 3 here, and then when you press the equality sign, you're ending up with an answer of 5. So I'm going to get an x value of 5. So x equals to 5 or x equals to something. What is something? All right, the other answer is what you're going to get when you change the plus sign from a plus to a minus. We are revising everything, so it's very important for you to just be good enough in terms of working with all these things. One answer comes out as 8 over 3. So the other one is going to be 8 over 3. All right, I've got x values. The examiner was not asking for the x values. They were asking for the x coordinate of the turning point of f. So these are the x coordinates. Remember, if they want the entire point, you're going to need to take these x values and substitute them back to the original equation and find out what is the corresponding y value of these turning points that you're working with. Let's just do that for the fun of it. Maybe if you're looking for the y value of the turning point, because I feel like you're going to need it to sketch, since they told us that we need to find the solution of the x values of the turning point. My brain tells me that we're going to need to draw the graph. We're not going to succeed to draw the graph if we don't have the corresponding y values. So how do you find the corresponding y values? You just simply take this x, you go substitute it back to the original function. Your original function, which is 2x cubed. The very, very original 2x cubed, wherever you see x, you're just putting a 5, and then you try to figure out what the corresponding y value is going to be. So let's go and fetch our calculator, and then we're going to substitute 5 everywhere where we see x in our equation. What was it? It was 2, open bracket. You've got 5 and then it's a cube, right? So 2 times 5 cubed, right? And then you're going to have a minus 23, and then you've got not a 2, but you've got a 5. You're replacing your x's with a 5. So minus 23 to the power square there of your 5, and then you've got plus 18, open brackets. You're going to put a 5 in that, and then you just simply need to subtract to 84 because this is how your cubic looked. And you have to make sure that everything is going on. It's going well so far. I'm getting a y value of -9. So y is going to be -9 when x is 5. And then you're going to go back to that very same calculation you did. You're now changing all the 5s. You're going to use a different x value now because you want to know what y is going to be when x is 8/5. So backspace that, put a fraction, and then there's your 8/3, which is the second x value. Let's move and try to substitute all the places that were 5s. We're going to replace all of them with a different number, which is 8/5. So backspace, create a fraction, put an 8/3. Okay, we're just replacing all our x's with 8/3. You go back, there's another 5 again. This is probably the last one. Backspace, fraction. We need an 8 here divided by 3. Then you press the equality sign, you're getting a very weird number. It is 100/27. So 100/27. It helps if you also express this as a decimal because you want to see where it's going to sit on your graph. It's 3.7. It's approximately 3.7. So this helps you if you think you might need to plot this on the graph paper. Very simple, not complicated. Now we go to the next question that says something very awesome. Now we need to sketch the graph of f, clearly indicating all intercepts and the turning points as well as the intercept with the axis. Okay, so how is the drawing going to look? I'm going to start first of all by putting this graph. We can all see it needs to have x-intercepts. Did we find x-intercepts? Of course, the x-intercepts are going to come from the factorized version of your graph. You're going to have an x-intercept at 7/2, another x-intercept at 6, and another one at 2. Very powerful, okay? So how do I normally draw my graph? I just simply go and say, okay, I need to draw the graph. I can even draw the graph before I put the Cartesian plane. So the cubic graph will just simply look like this. There's nothing wrong with doing what I did here. Put your graph, you're going to put the Cartesian plane after. So there's my Cartesian plane. There's the x-axis, right? This graph is going to have 3 x-intercepts at those 3 points. One x-intercept is 2. One x-intercept is 6. The other one is 7/2. 7/2 is 3.5. So we're going to have 1 as 2. We're going to have 1 as 7/2. We're going to have 1 as 6. So those are the x-intercepts that you're simply going to have in this particular question, because that's actually 3.5. That's 7/2. Now I need to find where the graph is going to pass on the y-axis. This graph is going to cut the y-axis at -84. So you're going to go and try and figure out where -84 is. But before you do that, your turning points need to play a big role. So this turning point here will be the turning point 5 and -9. And then this turning point will be the turning point 8/3 and 100/27, just because of the positioning of what you're looking at. So clearly, you can all see that the y-axis needs to be this side of your graph. It needs to be this side. And of course, it's not drawn to scale, but this is basically where it will cut your y-axis. So that's just more or less an idea of how this graph would look if you had to draw it. If you can start with the cubic graph, if you know the shape of it, and then you can be able to figure out the solution after without any problem, provided you understand the story when it comes to the shape of the graph as guided by the A value. Ours was positive, so this is how it looks if you're dealing with a positive value. You can always paste the Cartesian plane after the graph, then your graphs will always look beautiful.